Hi students, how are you all? Welcome back to our channel Light Rays Physics from Rohith Kokkula. In the part 2 we have studied reflection of light at plane surface. So why we have dealt with this? Because this part 2 will work as a basic building block for the part 3, that is Introduction to Spherical Mirror and its reflection laws, its terminology. So what are these curved surfaces? We have studied already in the previous chapter, previous introductions. But let us recall once again here as a small bit and let us discuss the most important parts called terminology. So this is a clip from the previous topic, that is curved surfaces. Here we have a plane surface which have bent to get a curved surface. A plane surface which is bent is called a curved surface. Now let us understand what is reflection of light at curved surfaces deeply. To study about the reflection of light at curved surfaces, first we need to understand what is a spherical mirror or curved mirror. Now here I have shown some images. The image which is to the right side is called concave mirror and the image to the left side is called convex mirror. Sir, they look the same. How to recognize them? You see, in the mirror, the object which are brushes are seen in a magnified way, means bigger in size. But if you see to the left side, we have a convex mirror where the mountains surrounding it are seen very smaller. So these are the properties of convex and concave mirrors which we need to use to recognize them. Now let us understand how these spherical mirrors are made. Initially they will take a hollow sphere. After taking the hollow sphere, they will take a silver or aluminium coating and they will start spraying on the hollow sphere. If they start coating from the inside, they will look like the right side top, and if they start coating from the outside, they will look like the bottom one. After the coating, they will take a glass cutter and they will cut the sphere in a straight line as shown in the video. Now if you turn the reflecting surface towards your side, you will get the image as shown in the video now. The image which is to the left is called convex mirror and the image to the right is called concave mirror. To represent these mirrors diagrammatically, they will use a curved surface and they will represent the coating with slants. These slants indicate the coating of the silver. The other side is the reflecting surface. You can see in the video I am highlighting the reflecting surface of convex mirror. Now let us understand the concave mirror. Now the concave mirror is shown diagrammatically as like this. First we have a curved surface, then we have the slants towards the coating surface. We have coated outside, so the coating is shown outside. Now the coating is done with the symbol CS and the reflecting with RS. Now reflecting surface is present inside the sphere, that's why we are seeing only the dark side outside. This arrow shows the coating present outside the sphere and that is shown with the dashed lines. Now the reflecting surface is present inside the sphere. If you turn the reflecting side towards you, they look like this. These are the spherical mirrors in the real life. So this is a convex mirror and this is a concave mirror. I am placing the concave mirror as a diagrammatic manner. The reflecting surface is seeing front and the coating surface is seeing back. This coating surface is shown with a dashed line and the reflecting surface is shown very cleanly. I am highlighting here. Now if I take a convex mirror, I am arranging as shown in the diagram. See, the coating is towards the left to right, that's why it is silver in color, and the right side is the reflecting surface. So reflecting surface is shown in the diagram like this and the coating is shown with the dashed line in the diagram with a CS symbol. Now let us understand how to recognize these spherical mirrors. You can see in the video as I bring the spherical mirrors close to the mobile, you can see that right side one image is getting magnified one and the left side is getting diminished one. The spherical mirror in which you are getting a bigger image is a concave and the spherical mirror which you are getting a diminished image is a convex mirror. Now let us understand the terminology relating to spherical mirrors. On the screen you can see convex mirror on the right side and concave mirror on the left side. Now I will take a scale and I will draw a diameter vertically to the concave as well as convex mirror. Now I will draw a diameter horizontally for the concave and now for the convex. Now let us join the midpoint of the two diameters on the spherical mirrors. Now let us remove the diameters. Now the points you can see on the screen are called pole of that spherical mirror. Now let us locate the pole sideways. Here I am marking a point for the concave mirror and now I am marking a point on convex mirror. These two dots are straight to the pole when seen from the side view. Now let us understand a new term called center of curvature. It is denoted by the symbol C. Let us take a concave mirror and produce a spherical surface from which we have cut this concave mirror. You can see a small dot at the center. This small dot at the center is called center of curvature of this concave mirror. We can say in other words that the center of the sphere from which we have cut the spherical mirror. Now let us take convex mirror and let us produce the sphere from which we have cut the convex mirror. Now you can see a small dot at the center. This dot at the center is called center of curvature for convex mirror. Now let us study about the principal axis of a spherical mirror. A line which passing from center of curvature and the pole of the spherical mirror is called principal axis of a spherical mirror. These two arrows which are drawn indicate that this principal axis can be extended on either side. Now let us see the principal axis for convex mirror. This line which is passing from pole of the spherical mirror and center of curvature is called principal axis of a spherical mirror. Now let us learn one more term called focus of a spherical mirror. It is denoted by the symbol capital F. Now let us draw a line that is parallel to principal axis. After hitting the spherical mirror, it will pass through a point. Now let us indicate the direction of the light rays with arrows. Now let us repeat the same activity for the ray below the principal axis. A light ray which is moving parallel to principal axis after reflection moves through a point. Now let us indicate the direction of light ray with arrows. Now these two reflected rays are meeting at a point called focus and it is denoted with the symbol capital F. Now let us measure the distance between C and F and P. Now you can observe on the scale that C is at 4, F is at 2, P is at 0 cm. The distance between C and F is 2 cm and F and P is also 2 cm. It means that the distance between C and F is equals to F and P. Now let us repeat the same activity for convex mirror. I am taking a principal axis and I am drawing the arrows to indicate it can be extended to both sides. Light ray which is moving parallel to principal axis, after reflection it follows a path as shown in the video. If I extend it back, it will meet at a point on the principal axis. Now let's draw one more ray which is parallel to principal axis, but it should be below the principal axis, and after reflection it follows a path. Again I will extend the rays in backward direction. It also meet at a point on the principal axis. This point where both rays are appearing to meet is called focus of convex mirror. It is denoted by the symbol capital F. Now let us measure the distance between F, P and C. Now you can see on the video that the P is pointing at 0 cm F is pointing at 2 cm, C is pointing at 4 cm. It means the distance between F and P and F and C are equal. Now let us arrange the two images of convex and concave mirror to the same size and let us analyze them. Now you can see on the screen the light rays which are moving parallel to principal axis are meeting at a point for concave, and the light rays which are moving parallel to principal axis are diverging away from a point on the convex mirror. These points on convex and concave mirror are called focus. It is denoted by the symbol capital F. You can observe that the distance between F and C and F and P are equal, and on the convex mirror F and P and F and C are equal. So we can say F is a midpoint between the P and C. So this is one more definition of focus. Now let us study one more definition called focal length. You can observe on the screen I am drawing a line at focus and I am drawing one more line at pole. Now the distance between focus and pole I am denoting with a single line. Now this length of the line is called focus. Now let's draw for convex mirror. I am drawing a line for pole and for focus. Now the distance between pole and focus I am showing with a line. So this line is called focal length. So if you want to say in simple words, distance between pole and focus is called focal length. Now let us study one more term called radius of curvature of a spherical mirror. Now I am drawing a point at C and a point at P. Now the distance between C and P is called radius of curvature R. Now I am repeating the same for the convex mirror, drawing a point at P and drawing a point at C. Now the distance between C and P is called radius of curvature denoted by symbol R. There is a relation between R and F, that is R equals to 2F. Now this is a relation between radius of curvature and focal length. Now this is the final image which shows all the terms very clearly. And that's all for today. Thank you all.